Hello dear students, I hope you all are fine and doing well in your studies. So students, we are done with the chapter of limits and derivatives as per the class 11th syllabus. And now it is time to do some questions which are asked in the previous years of JEE mains examination from this particular chapter. So without delaying further, let's get started with the questions of previous years of limits and derivatives.
So let's begin. First question says limit x tending to 0, x plus 2 sin x divided by under root of x square plus 2 sin x plus 1 minus under root of sin square x minus x plus 1. So we will have to evaluate this limit. When x approaches 0, this is basically a limit of the form 0 by 0. Now, upon observing these two terms which are present in square root, we can have an idea or thought process of rationalizing first the given function. So I can write it down as limit x tending to 0, x plus 2 sin x divided by this quantity which is x square plus 2 sin x plus 1 minus root over sin square x minus x plus 1. We can have over here x square plus 2 sin x plus 1 plus square root of sin square x minus x plus 1 divided by the same quantity, that is root over x square plus 2 sin x plus 1 and root over sin square x minus x plus 1. Alright, now in denominator we can apply the formula of a minus b and a plus b, which is equal to a square minus b square. So in denominator we are going to get x square plus 2 sin x plus 1 minus sin square x minus x plus 1. In numerator we are not going to make as such any change for now. So I am writing down x plus 2 sin x and then these two terms as it is. So now we are having limit x tends to 0. In denominator we can have x as common from all the terms. So we are left with 1x over here and this terms becomes 2 sin x by x, and then we have minus sin square x divided by x and plus x divided by x will be equal to what? 1. And in numerator we have x plus 2 sin x multiplied by these two terms as it is. Alright students, so we can say that when x approaches to 0, we will have x plus 2 sin x and divided by x in both the quantities, and over here the limiting value comes out to be 1 and over here the limiting value comes out to be again 1. So 1 plus 1 equals to 2 divided by 3. Now when x is approaching to 0, the limit over here comes out to be 2 plus 1 following the standard rule, standard limit. So we have 3 divided by 3 which is equal to 1 and it is multiplied by 2 in the numerator. So the answer comes out to be equal to 2. This is going to be the final limit of this question. So this question involved a bit of calculation and it was a bit time consuming, but overall it was a moderate problem which was asked in 2019 JEE mains exam. So the correct choice corresponding to this question is given in choice B. I hope everybody must have understood. Let's move further. So this question says if limit x tending to 1, x square minus ax plus b divided by x minus 1 equals to 5, then a plus b is equal to. So let's begin with the solution part of this question. Let us first check the indeterminacy of this particular function. When x is approaching to 1, denominator approaches 0 and numerator, this becomes 1 minus a plus b. So for the existence of limit, this must be an indeterminate form of 0 by 0. Since denominator is approaching 0, numerator must also approach 0 in order to make an indeterminate form. Alright students, because it has been given that limit exists and it is equal to 5. So simply we have got that when x approaches 1, we have 1 minus a plus b. So 1 minus a plus b has to be equal to what? 0. So let us consider that this is relation number 1 that we have got between a and b. In order to determine the limit, let us do some manipulation. X square minus 1 plus 1 and minus ax plus a minus a plus b. What I have done in the numerator, I have added 1 and subtracted 1 and added a and subtracted a, and rest all terms are as it is, that is x square minus ax and b. Now let's arrange the terms a bit. X square minus 1 is going to be x minus 1, x plus 1 plus 1, and from here we can have minus a as common and we are left with x minus 1, and then we are left with minus a plus b. I hope everybody is getting till here. Now upon separating each and every term, this x minus 1 can be cancelled off with the denominator x minus 1, and this x minus 1 can again be cancelled off with denominator x minus 1, and we already know that 1 minus a plus b from relation number 1, it is already equal to 0. So I think we do not have any problem in evaluating the limit. Let's separate the limit. We have limit x tending to 1, x minus 1, x plus 1 divided by x minus 1 plus limit x tending to 1, a into x minus 1, and this is with a negative sign, so let's multiply with minus 1 and divided by x minus 1. Alright students, because 1 minus a plus b is already equal to 0. So from here we get limit as 2, and from here we get minus of a, and this has been given to be equal to 5 because the entire limit was equal to 5. So let's equate this with 5. So we can have from here the value of a to be equal to minus 3, and from relation number 1, when a is substituted as minus 3, this becomes 4 plus b equals to 0. So b comes out to be equal to minus 4, and we were required to find a plus b, so a plus b is equal to minus 7. So corresponding to this, we have been given correct option in choice C. Alright students, I hope everybody must have understood this question. Let's move further. So here we have, if limit x tending to 1, x raised to the power 4 minus 1 divided by x minus 1 is equal to limit x tending to k, x cube minus k cube divided by x square minus k square, then k is. So let's begin with the solution part of this particular question. Let us first evaluate this limit. Now it is very easy to evaluate this limit. We can just factorize x raised to the power 4 minus 1 as x square minus 1 multiplied by x square plus 1 using the identity of a minus b and a plus b, and this can be further factorized as x minus 1 x plus 1 multiplied by x square plus 1 whole divided by x minus 1. Now when x approaches 1, these two factors in numerator and denominator get cancelled off, and we get the limit. This is 2 and this is also 2, so the entire limit comes out to be equal to 4. Alright, now the limit that is present over here in RHS, limit x tending to k, x cube minus k cube. So let's factorize x cube minus k cube as x minus k, x square plus kx plus k square, and x square minus k square as x minus k multiplied by x plus k. Alright students, we have simply used identity of a cube minus b cube and a square minus b square. I hope everybody must have understood. So when x approaches k, these two get cancelled off, and we can simply evaluate the limit because indeterminacy is gone now. So this becomes k square plus k square plus k square. So numerator is 3k square divided by denominator becomes 2k. So we are left with 3k by 2. Now since both of these limits are equal, so we can say that 3k by 2 has to be equal to 4, because over here it is 3k by 2 and from this limit we got 4. So k is equal to 8 by 3, which is given in option D. So this was a pretty simple problem which was based on finding the limit using the method of factorization. I hope everybody must have understood this particular question. Let's move forward. So in this question again we have been asked about the limit x tending to 0 sine square x divided by root 2 minus root over 1 plus cos x, and we have been asked that this limit is equal to which of these 4 options. So let's begin with the solution part. Now one can easily observe this is an indeterminate form of 0 by 0. Alright, now in order to evaluate the limit, since square root term is present, so we can again have an idea of rationalizing the denominator. So what we are going to write? We are going to write root 2 plus root over 1 plus cos x in denominator as well as in numerator. Alright students, now in denominator again we are going to apply a minus b, a plus b identity. So this becomes equal to limit x tending to 0 sine square x divided by 2 minus 1 plus cos x multiplied by numerator will remain unchanged, 1 plus cos x plus root 2. Alright, now 2 minus 1 plus cos x becomes 1 minus cos x. So we can write limit x tending to 0 sine square x divided by 1 minus cos x multiplied by root over 1 plus cos x plus root 2. And now 1 minus cos x when multiplied divided by x square. So this limit, as we already know, is equal to half, and this is making a standard limit of sin x by x. So I hope there is no problem in evaluating the limit now. Sin x by x is equal to 1 and 1 minus cos x by x square, its limiting value is 1 by 2, and this quantity when x approaches to 0 we get 2 root 2. So overall we are going to get 4 root 2, and this is our final limit of this question, which has been given in choice A. So choice A is the correct option. I hope everybody must have understood. Let's move further. So again we have limit x tending to 0 for this function, and corresponding options have been given. So let's directly begin with the solution part. We have limit x tending to 0 x. This cot 4x can be written as 1 by tan 4x multiplied by, we have sin square x multiplied by, this cot square 2x can be written as 1 over tan square 2x, and this tan square 2x gets shifted in the numerator. Alright, I hope everybody must have understood our first step that we have done. So now we have limit x tending to 0 x multiplied by tan square 2x divided by tan 4x multiplied by sin square x. Now this is a 0 by 0 form. So in order to evaluate the limit, question simply gives us an idea of standard functions. We can simply evaluate the limit using the standard limits of tan x by x and sin x by x. We all know that limit x tending to 0 sin x by x is equal to 1, and limit x tending to 0 tan x by x is also equal to 1. So we are going to make standard limit. So for this tan 4x we will be needing a 4x in the denominator, so I am multiplying dividing by 4x. For this sin square x we need x square in the denominator, so I am multiplying and dividing by x square. And for this tan square 2x we need square of 2x, which is 4x square, so again dividing and multiplying this term by 4x square. So we have converted each and every term according to standard form, and limit can now be separated to each and every term. So in numerator, x multiplied by 4x square becomes 4x cube, and this 4x multiplied by x square again becomes 4x cube. So these terms in the numerator and denominator get cancelled off, and now the indeterminacy is gone. We have this limit as equal to 1. We are going to get the answer as to be equal to 1 using these two standard limits. So corresponding to this question, choice B is correct option. So I hope everybody must have understood this particular question also, which was asked in JEE Mains Examination 2019, and it was also a very easy problem based on standard limits of trigonometric functions. Let's move further to see our next question. Now we have again a question of limit. We have to evaluate limit y approaches to 0. The function is root over 1 plus root over 1 plus y raised to the power 4 minus root 2 whole divided by y raised to the power 4. Alright, and we have been given options. So let's begin with the solution part of this question. So again, when y approaches 0, this term is root 2 minus root 2. So numerator approaches 0 and denominator also approaches 0. So this is basically again 0 by 0 indeterminate form. So again, due to the presence of square root, we are going to use rationalization method. So we can write limit y tending to 0 or y approaches to 0, this term minus root 2, and now we are going to multiply divide by this term. So both of these terms will be present in numerator as well as in denominator, because we are multiplying, dividing, or we are performing the rationalization of numerator. Alright students, now again we are going to use the identity of a plus b and a minus b in these two terms, which is equal to a square minus b square. So we are left with 1 plus y raised to the power 4 ka square root minus this becomes 2. We have just applied a square minus b square for these two terms. This was a and this was b. And in denominator we have y raised to the power 4 multiplied by this term. Alright students, now numerator can be written as 1 plus y raised to the power 4 whole raised to the power 1 by 2, this term, and 1 minus 2 equals to minus 1 divided by y raised to the power 4 and this bracket, which consists of the term this plus root 2. Alright, now we can use the binomial expansion. When y is approaching to 0, this term is very small in comparison to 1. So when x is very small in comparison to 1, we can say that 1 plus x raised to the power n is approximately equal to 1 plus nx. Alright, according to the binomial, we can say that we can approximate 1 plus x raised to the power n with 1 plus nx when x is very small compared to 1. So now we can write numerator as limit y tends to 0, 1 plus y raised to the power 4 multiplied by 1 by 2. This n gets multiplied with this term minus 1 divided by y raised to the power 4 and under root of 1 plus root over 1 plus y raised to the power 4 plus root 2. And now I think we are done with the problem. Y raised to the power 4 gets cancelled off in numerator and denominator, and indeterminacy in the question is gone now. So in numerator we are going to get half, and in denominator we have this term root 2 and this term root 2. So denominator becomes 2 root 2. So the final answer becomes 1 upon 4 root 2. Alright students, which is given in choice A. So this was a bit manipulative, where we have used first rationalization method. We have done the rationalization of numerator, and then we have used the binomial expansion in one step, that is 1 plus x raised to the power n is approximately equal to 1 plus nx, and then we have evaluated the limit because indeterminacy in the problem is gone. So this was a moderate level problem which was again asked in the year 2019 JEE Mains Examination. I hope everybody must have understood. So let's move forward to see our next problem. Now we have a question which was asked in JEE 2017 Mains Examination, and this question is again based on limit. We have to evaluate the limit x approaches to pi by 2, function is cot x minus cos x divided by pi minus 2x ka whole cube. So let's begin with the solution part. When x is approaching to pi by 2, so we have 0 in numerator and 0 in denominator as well. So this is again a 0 by 0 indeterminate form. Alright students, now in order to evaluate the limit, since we have been given trigonometric functions and x is approaching to pi by 2, so we can use over here the method of substitution. We can replace x with pi by 2 plus h. So when x approaches to pi by 2, h has to approach to 0. So this limit can be now written in terms of h, limit h tending to 0, cot, in place of x we are going to get pi by 2 plus h minus again over here pi by 2 plus h, and in denominator as well pi minus 2 times pi by 2 plus h whole cube. Alright, now as we all know that cot pi by 2 plus theta is equal to minus tan theta, so this becomes minus tan h, and cos pi by 2 plus theta is minus sin theta, so next we have sin h whole divided by denominator becomes minus 2h cube, which is minus of 8h cube. So now I can have limit h tending to 0, upon taking sin h as common we have 1 by cos h minus 1 divided by 8h cube. Alright students, we have first taken sin h as common and minus 1 gets cancelled off in both numerator and denominator. So I hope everybody must have understood till this point. So again we have limit h tending to 0, sin h divided by h, and we have 1 minus cos h divided by h square, because we had h cube, so h cube has been broken down in two parts. First one is h multiplied by second one is h square. So this h cube gets adjusted in these two terms, and now we are left with a 1 by 8 which can be taken out of the limit, and a cos h in the denominator. Alright students, now using the standard limit, 1 minus cos h over h square will be equal to half, and sin h by h will be equal to 1. We already know the limiting value of these two functions using the standard limit of trigonometric functions, and when h approaches to 0, cos h is equal to 1. So overall we are going to get 1 by 8 multiplied by 1 by 2, which is equal to 1 by 16, and corresponding to it option has been given in choice B. So choice B is the correct option. So I hope you must have understood this particular question also, in which first we made the replacement of x as pi by 2 plus h. You could have also done the replacement in this way, that x could have also been kept as pi by 2 minus h. No problem in this substitution. The problem will be solved with this substitution as well, but we have used pi by 2 plus h, and we have replaced x everywhere with pi by 2 plus h, and limit is now h tending to 0. And after that, upon the arrangement of terms, we have just used standard limits of trigonometric functions in order to arrive to our answer as 1 by 16. Alright students, so I hope everybody must have understood this particular chapter and this particular session on previous year's questions. So we will meet again with a new chapter in our next session or next lecture. But this is it for today. See you again. Thank you.